Welcome to another video episode on my Arduino Mega2560. Right here. It's connected physically to breadboard with a lot of electronics, some fischertechnik mechatronics, and an Arduino Uno. The wiring between those are SPI, serial prefer interface, and I2C. Now, lately, with some experiments finished, I wanted to return to the base and find out why the mechatronics, more specifically these two, are not responding as they should. And that led to some other findings, being that this board didn't want to power up anymore. At least some values were not taken correctly. I had to use an alternative power supply right here, and then things started to work out, kind of. The values of the pulse modulation for controlling the mechatronics and the LEDs, a lot of LEDs here, all controlled by pulse modulation and connected to an oscilloscope. They didn't give the values that I expected to see. Then I decided to start all over. Keep the wires intact, but reprogram. And that gave another surprise, because taking this Potmeter, programming it again, using the wiring, gave the problem that it didn't work out anymore. And right now I notice that this wire is not connected anymore, which is the plus, which is right here. And then another wire is gone, and that is right here. And it is 5 volts and the other one is 3.3 volts. But now for some reason this works again. So let me disconnect and reconnect. So that's important. This means that this connection is still working somehow, because this one is connected to the Uno. However, what does this one do, if anything? So my first idea is to change the setting of this potmeter, because this one, which is the same model, is directly connected and seated into the breadboard, and this one isn't. So I want to change this one, that it again sticks completely into the breadboard, and then see if it works again, because that through the serial monitor I found that those values were not representing the way I dealt with it. So first change this one and then see further. Alright, so now basically this is fixed. It's now stuck straight into the breadboard, just like this one. I put one of the wires that I got off of it into the same lane as the measuring leg or wire actually, with a probe, so I can now measure this one. which doesn't do a thing. And that was exactly the problem last time. What does it do? What doesn't it do? So let me check correct board. Let me select the correct port, which is this one. And then time to... Oh, really? Wow, that's something different than last time, because last time it gave all zeros and maybe some other value. So going here, yeah, how to do this, because I want to see that value. Okay, let's do it this way. So I want to turn this one, see a different value here, a very different value, and also see it here. So here goes. Okay. So this is a very clear result on the oscilloscope. Yeah, and with the potmeter as well. Okay. Alright, I'm very happy with this result, I can tell you. Very different, very welcome, very nice result. So what to do next? Well, since this is originally intended for this motor, and let's not forget for this motor as well. So this one has a switch which lets this one stop, but this one controls the speed of this one. So that's next. So this works nicely, very nicely indeed. Now where is this one connected to? Ah, here comes the schematics. So I forgot to put those one on. Let's see. What to do this one? Yes. Yeah, and then I have to find it. So let me do just that. Alright, I checked the wiring and indeed it is from port 7. So I need to address this port. This one goes back. And it's coming from here. Goes straight. It goes actually here with a yellow wire here, resistor, then with this transistor, and then to the motor. So what next? Well, this will be an output. Analog out, pin 7 is 7. Analog output 4. motor with chain. That's one thing. Then pin mode 7. Output. And then the other thing happens, because in the past I did something like just a direct direct value, and then I learned I had to actually map it. So I'm going to try both. First the direct value. And I know which value is here, so let's say analog right, out pin 7, and then write this one. So this will be then the direct pulse. Oh, which gives a problem, and that is probably why I can't use this away, because it's 8 bits. 2 to the power 8 is 256. So I have to limit that, and that's why I have to do the mapping. So instead of doing this, I have to copy from my old from this one, and go way back into the coder. And then got it here. So let's take this one and put it right here somewhere. But output value 1, well, let's say output value motor 1. And that will not be sensor value. This will be this one, and this one will be here. So now I'm very curious what will be. Let's comment. So this is no, this is just definition of what it is, and here I have to comment for what it is. So let's keep this and see whatever happens. Now I'm getting curious. Oh, right. Not declared. And output motor 1. This will be better. This is C. Although it's AVR C, it is C language, so I have to declare every variable that I use. Now, can I make it run? Well, so far it doesn't run at all. And it is, as you can see, halfway the scale. And it doesn't do a thing, it doesn't do anything. So, what I need is to expand the code. And actually print the value. So output motor 1 is, and then print line, and then you get what? Output motor 1. So then I do know what is being printed. And this goes way too fast. So let's, okay, 117. Okay, 117 it is. 117 is nowhere near, no, it's halfway, say 256. Alright, now fully to one side, which is 0. Completely to the other side, which is full value. Then see, full value gives next to actually full scale value of 256, so that's good. Except that the motor doesn't run. So why doesn't the motor run? And that's not a question. So let's find that one out. Alright, I decided to change the setup a little bit and follow the same thing like I did here and there, which means that I put an LED in between one side of the transistor and the ground, which is this little transistor. The only problem is it works and here it doesn't. So actually going here, this is one, but behind the transistor and this one, or wherever the ground is, right here, there's supposed to be an LED now. Where do I have an LED? Right here. So let me just copy it. And change direction. So somewhere, this one goes somewhere here. Anyway, okay, let's save this. It doesn't work yet. So what I'm going to do is to skip the transistor for now. And I'm going to rewire this one to, oh, that's an odd one, so it always worked and then suddenly it doesn't. So where did I put the wire? Right in the middle. And I should put it here. And what is the common wire is right here. Yeah, and neither works. So this LED obviously does work, but it should work like this. And I had the same problem before in other situations. So, one new mystery. Why is one thing working and the other doesn't? Very good question. Which right now I unfortunately cannot answer. It's the same situation here, it is the same situation here. Why oh why? Doesn't electronics always do what you intend? Well, usually it's your own fault. And then find the fault. But I'm always glad that this part is working. Oh really? Where's the whining coming from? When I press this, I hear a motor whine. You got to be kidding. So this potmeter is from this motor. Yeah, right. Really. Well, it is a motor with chain, but I thought that was this one. And now apparently I fixed this one. For no apparent reason. So, with that in mind, I better check the other potmeter. So here's another one. Where is that one connected to? This one is connected to oh, I made a mistake. Wait. This one, let's see, this is input A0. So this one has to be input as well. I need to check this part of the wiring. Because what I thought was 7, and that is output 7, goes straight here. Which one goes and this is a 0. So with this finding, I know I have to check this circuit completely, because 7 indeed goes here. So I am controlling this one. With this one, I am indeed controlling this motor. And that's a matter of programming. So where does this one come from? That one comes from actually 6. So in the remaining time, let's do that one. So copy, and let's keep it in sequence. This is 6. This is 6. 6 for output, and let's say 6. So then it controls both motors for now. Let's check that one out. Well, this one clearly does work, at least in theory. Just this one doesn't. So this connection needs to be re-evaluated, so to speak. Cluttered wires. This one works. Now this one is indeed doing what it is supposed to do, but it doesn't run. Okay, and time has gone by. Time is up. Alright, my apologies for the last part of the last segment, where I didn't look at my screen enough. So now this is working. This one is working, because I'm now sending it really also through the wires 6, which is connected here, and 7, which is connected there. So that works, except for the fact that when I wiggle this potmeter, it works, and this one doesn't. So that's a bit strange, or very strange. So why that is, and then the question is, for which one is this potmeter? Cluttered wires here, so I need to refigure out which wire is going to which input. And that comes next time. So in fact I'm reinventing my own circuitry. Not bad, but I'm very happy that at least the board is fully functioning for now. So after this restart, thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, like it, leave a comment or suggestion. You can also follow me on Instagram. Please like it, leave a comment. You can also follow me on Twitter. Please retweet, like it, leave a comment. You can show your support by making a small donation via PayPal or Wired. More information at the start of the video or on my website, which is listed in the description box under the video. And you can also choose to become a patron and have your name mentioned. And more information is on my website, as well as on my Patreon site, and more information under this video. This is obviously going to be continued, so thanks for watching and bye bye.